Okay guys, so this is just a quick overview of barriers to infection in the body. And when we're talking about barriers to infection, I want to be really clear, these are not part of the immune system. Your immune system is to do with fighting off infections and then gaining immunity to it, so not being able to be infected by it again. The barriers to infection don't fight off infection, they're just there to stop you getting infected, okay? So like I say there, the purpose of them is to prevent an infection happening in the first place. So to either stop the bacteria or virus or fungi or whatever getting into your body, or to stop it taking hold in your body. And we can break that into three different categories. So there are physical barriers, which stop pathogens entering. There are chemical barriers to control growth of the pathogen, and microbiological barriers to control growth of the pathogen and to prevent colonization. The last one, the microbiological one, I always find really interesting. There are more bacteria cells in your body than human cells. Obviously, bacteria cells are much smaller than human cells, so they're all packed down there mostly in your guts, your intestines. But if you count up the individual cells, there are more than human cells. We used to believe that it was 10 times more than human cells. We now believe it's in the region of about 30 trillion human cells to 39 trillion bacteria cells. So not a 10 times difference, but still a pretty significant difference. But basically, those helpful bacteria in your guts, by the fact that they exist there, that should stop an unhelpful bacteria, a pathogenic bacteria, from taking hold in that area. So that's the way it works. By them living there, it prevents something unpleasant starting a home there, pretty much. So, as you well know, I am not an art teacher for a reason. I tried to draw a human and this monstrosity happened. The poor bloke's got one of his arms much bigger than the other, one of his legs much bigger than the other. He's got a weird misshapen head. He's probably from Leeds. Anyway, but I've just annotated onto this unfortunate fellow some various things. The red is meant to represent a chemical barrier, the black represents a physical barrier, and the blue represents the microbiological barriers. Okay? So first of all, we've got skin to prevent entry of the pathogen in the first place. I've also put there's a mild pH effect too, so your skin has a slightly acidic pH, which can help prevent bacteria living on your skin as well. But basically, the skin covers all of your body, it covers all of your internal surfaces apart from a few places where there are openings, obviously your mouth, eyes, etc. But by keeping that skin intact, that prevents pathogens getting inside your body for the most part. And that's why when a cut happens, the body acts really quickly to seal up that cut as quickly as possible to prevent things getting in while the skin is broken. Okay, moving up from there, obviously at the top there I've got tears and saliva. Tears and saliva both contain lysosome enzymes, and lysosomes will break down bacteria. So some bacteria that get into your mouth or into your eyes will be broken down by enzymes present in your saliva or in your tears. I've put mucus. Mucus obviously traps pathogens, and then you can cough it back up. So that's something that mucus does. So two more physical features. We've got your eyelids, which are really just a specialised version of your skin. So they've got involuntary control. If they see something coming towards your eye, they shut, which obviously protects your vision, but also stops things that may carry bacteria getting into your eyes. And they keep them on the outer surface of your eye as well. And then we've got cilia. Cilia are microscopic hair-like extensions of cells, and they are found in many places in your body, but they're particularly noticeable in your throat cells. And what they do is when things that could carry bacteria or viruses, etc., settle on those throat cells, the movement of these hair-like extensions moves them down to your stomach where they may be absorbed, or it may move them upwards so they can be coughed out. Okay, so cilia are another physical protection. I've then got the stomach acid. So your stomach has a pH of around 2, a very low pH, and a low pH means very strongly acidic. And that destroys most bacteria. And then we've got the gut flora that I mentioned before, which again are providing while they help with your digestion, the fact that they exist in such large numbers makes it difficult for a pathogenic bacteria to colonize your guts as well. It can still happen though. I mean, I know it seems strange that we can even get infected at all with all these things going on, not to mention the immune system we'll start looking at. But it is worth pointing out that when bacteria and viruses take over, it's not just one bacteria or virus, it's usually hundreds of thousands of them, okay? Many of the bacteria that cause food poisoning, they must be present in numbers, hundreds of thousands of them, okay? So your body, these barriers in your body can do a lot to protect you from bacteria and the other pathogens, but if they're present in high numbers, they can't do anything, okay? Or they can't do enough at least. So that really covers everything for the human barriers, but there's just a little bit to talk about with plant barriers. Not too much to say about them, but just be aware that a few things they have is they may have thick cuticles. Cuticles are often covered in a wax layer, and that makes it difficult for pathogens in water to get through to the plant. The fact they have a cell wall is really helpful. You may remember from the last lesson, viruses like to get into cells. It's more difficult for them to get into a cell if there's a cell wall as well as a cell membrane. So we as animals, we don't have a cell wall. Plants have a cell wall and a cell membrane, so it's an extra step of protection, really. The size of stomatopores. So stomata are really small holes on the underside of leaves to allow gases to get in and out. And the smaller they are, the more difficult it is for pathogens to enter through those holes. And then, plants also produce some antimicrobial chemicals as well, so some chemicals that destroy bacteria. Worth pointing out, though, that again, with all those things, plants can still be infected by bacteria, and quite often are. You may think it's perhaps interesting that we can eat plants raw, but many plants raw, but we can't eat animals raw. And a lot of the time, the plants that we eat raw are still actually full of bacteria, not too dissimilar to how a raw bit of meat may be. But because the conditions of a plant are so different to the conditions of an animal, it's very difficult for those bacteria to colonize us, which is why it's fine for us to eat raw plants, but not okay to eat raw animals. Okay, that is everything from me. Thank you very much.